Okay, so in this video I'm going to show you how you can work this problem. It has multiple steps to it, so I think the best thing would be for me to just kind of walk you through it. So my particular problem is asking for the probability of being dealt 4 cards of one denomination and 2 cards of another in 6-card poker. So our magic numbers are 4 cards of one denomination, 4 of one, 2 of another, and this is 6-card poker. So there's several steps that we have to go through. So I'm going to go to a whiteboard and kind of try to go through this step by step with you. So the first thing that we want to do is, let me see if I can make this a little bit bigger here. Okay. The first thing I want to do is step 1. So with step 1, what you want to do is we just want to figure out how many different hands we can get. So that's going to be our total number of hands we could have in 6-card poker. So we need to find out, first of all, there's 52 cards. So we know that X is going to be the objects we're going to select. So we're going to select 6 cards, and N is the total number of objects, and there's 52 cards in a deck. So we need to find the combination of N, C, X, which is 52 combination of 6. Now I'm writing with my fingers, so I apologize for it being so sloppy. So the formula for combinations is on top is n factorial. So 52 factorial over n minus 6 factorial, so 52 minus 6 factorial. I think that's n minus x. And then the last part of the formula is x factorial. So as you can see, this is the formula. So we plugged everything in. Now we just need to solve this. So I'm going to erase up here and show you how to solve this. So something I learned when I, first of all, we could simplify this and change this to 46 factorial. So basically we're left with 52 factorial over 46 factorial times 6 factorial. So let's just keep that in mind. And let me just show you how you could simplify this if you didn't have a calculator with the factorial button. One thing you can do is, since you have 46 factorial on the bottom, we could go from 52 times 51 times 50 times 49 times 48. I'm running out of room. Let me start over here. So on the top we have, I'm going to start at the very beginning. At the top we have 52 times 51 times 50 times 49 times 48 times 47 times 46. Now keep in mind that we did 52 minus 6 and got 46 on the bottom. So if you can get to the number on the bottom that are the same, then you can cancel those out. And then we had 6 factorial still down on the bottom. So 6 times 5 times 4 times 3 times 2 times 1. And what you can do, I do know the bottom is 720. The top was a really, really big number. So what I did was I did that in my calculator. I put in 52 times 51 times 50 times 49 times 48 times 47 times 46. Not 46. I did that in the calculator and I got a really big number. And then I just put divided by 720. So when I did that, here is the total number of combinations I got. I got 20,358,520 different 6-card poker hands I could get. So you need to remember that number. That's the total combinations. That we're going to need that number at the end. Okay. Now, so we've got that. Step 2 is going to be determine the number of ways we're going to do the first part of the 4 cards. Remember, back to my problem, it says something about 4 cards of one denomination. Let's do that one first. So we have 4 cards of one denomination. And remember, in poker, there are 4 different suits, okay? So we're choosing from 4 different suits, and we want to know from those 4 suits the combination of getting the 4 of the same. So this one's going to be fairly easy because you get 4 on the top. N and X are the same thing, so you do 4 minus 4 and then 4. So basically what happens here is 4 minus 4 is 0 factorial, which is 1. Anytime you get 0 factorial, it means 1. These two cancel out. So there is one way to select 4 cards of one denomination, assuming it is selected first, okay? So there's one way, okay? Now, we have one way, and then we have 13 different denominations here. So if we do one way and times 13 denominations, we would get 13. So 13 is our number for the 4 cards of the same suit. So we need to remember 13. Okay. Now let's think about 2 cards of one denomination. So remember we have 4 suits, and how many combinations could we have of getting 2 cards of the same denomination? So 4 times 4 minus 2. Notice you subtract just the way it looks, and then it's always the second number goes there. So 4 times, I could simplify this and say 4 times 3 times 2. I would stop there because I have a 2 on the bottom. Really, I have 2 factorials of 2. Only one of them will cancel out. So I end up with 12 over 2, which is 6. So there are 6 ways to select 2 cards of a specific denomination. Other than the one selected for the 4-card denomination. So if we've already selected for the 4-card denomination, then we only have 12 denominations left. So 6 times 12 would be 72. So the number of ways to of getting 4 cards of one denomination and 2 cards of another was 13 times 4 combination of 4 times 12 times 4 combination of 2. So we ended up getting 13 times 1 times 12 times 6, which ends up being 936 combinations of getting 4 cards of the same denomination and 2 cards of the same combination, the 6-card poker. So what is the probability? What you have to do is you have to take your combinations, 936, and divide. Remember that big number, the 52, not 52, but the different 6-card poker hands I could have, the 6 different combinations I could have, it was this number. Remember at the beginning I said we're going to need that again? Well, there it is. So if you divide that top number by the bottom number, that was a 0, not an 8 at the end. If you divide that, you get a probability of 0.00004598. So the probability of you getting in 6-card poker 4 of the same suit and then 2 of the same suit is very, very, very small. It would be 0.00005 because we had to round. So that is how you do this problem. I know that is a lot of steps, so you may want to rewind and go through them again. Probability is not really my favorite thing, neither are combinations. But a lot of students do well with this just because they understand poker and cards and odds. So hopefully this will help. This was a difficult problem, so try to follow the steps that I took, and you can also go on Question Help and view an example. It's kind of the same thing that I just went through, but if you need to see like the formulas. Now in this example, if you want to try to work it after watching mine, this one was 4 cards of one denomination and 3 cards of another, and then we're using 7-card poker instead of 6-card poker. So you could try to work this one along with the example, and that could help you work this problem, but you will not have one this complicated on any test.